All right. So with this right here, somebody tell me what this length would be right here. 25. All right. The reason it's 25 because it's an isosceles right triangle, which automatically means these two are equal. How do I know those are equal? Because if that's 45, that's 45, which means the sides are equal. Now, for those of you guys who are paying attention, then x is equal to what? Thank you. 25 radical 2. All right. Just to remind those of you guys, 45 to 90, you're getting bigger, correct? So all you have to do is multiply by radical 2. If I wanted to go from the 90 to the 45, what would I do? Divide by radical 2. That's the process. That's all there is to it. So if you're looking at 19, x would be what? 17 divided by radical 2. Beautiful. And then those of you guys who are one step ahead of the game, you're not allowed to have radicals in the denominator. So you multiply the top and bottom by square root of 2. And when you do that, you end up with 17 radical 2 over 2. Andrew, you with me on this? Again, there's not a whole lot involved here. All right, not a whole lot. All right, so here we go on 21. All right, this is 45. So to get to x, I just do what?
You have to, you have to divide by.
Yes.
Radical 2.
Divide by radical 2. And one way I told them, Andrew, was you're getting smaller. You're going from a hypotenuse to a leg, so it's getting smaller. Smaller, you're going to divide. So now when you rationalize, you end up with 100 radical 2 over 2, which simplifies to 50 radical 2. And so on 22, we're going to say that's what? 100 radical 2. All right, we're going from the 45 or from a smaller side to a larger side, so you multiply. All right, now the rules for the 30, 60, 90. All right, the rules for the 30, 60, 90. We said going from the 90 to the 30. Who remembers? 90 to the 30, what do we do? Help me. What? Say it. Divide by 2. Thank you very much. All right, divide by 2. So what do you think it means if I'm going from the 30 to the 90? What do you think I do? Multiply by 2. From the 30 to the 60, what do I do? Multiply by radical 3 because I'm getting bigger. All right, so that means to go from the 60 to the 30, what do we do? Divide by what? Divide by radical 3. Simple little pattern. Simple little pattern that everyone should know. So now someone tell me the 11, is that correspond to the 30, to the 60, or to the 90? 30, exactly. Because the angle opposite determines the size of the side of the triangle. So what would x be, guys? 22. What would y be? 11 radical 3. That's it. All right. Now, 8 radical 3 for number 27 is the hypotenuse. So what is y? Thank you very much for that. Dividing by 2, 4 radical 3. Now, how do I get from the 30 to the 60? How do I get from the 30 to the 60? Multiply by radical 3 because you're getting bigger. So now you have to remember how to do 4 radical 3 times radical 3. What's radical 3 times radical 3? 3. You can say radical 9, but you should just say 3. Then 3 times 4 is what? 12. Anybody have any issues with that? All right, once again, everybody take a look at 29. This is the 30. Opposite the 30 is always half the hypotenuse. Opposite the 30 is always half the hypotenuse. So what is X? 15. And what is Y?
15.
15 what?
Radical.
15 radical 3. All right. Now 21 radical 3, what angle does that correspond to? The 60. So then what is Y? 21. And what is X?
42.
42. All right. Everybody put down what they think X and Y are. All right, then you can see if you know what you're doing. All right, everybody take a look at 31. What?
That's what the Peter expects, so
Great.
I just-
Now, again, I always identify the 30, 60, 90. So this, the green represents the what?
30.
30. The red represents the what? 60. Beautiful. So Y is how much? 26 radical 3. Beautiful. And what is X? How much? I agree. Because 26 radical 3 times radical 3. Is everybody with me? Radical 3 times radical 3 is 3, and 3 times 26 is 78. So I'm totally happy with that. All right, everybody take a quick look at 37. This is a cool little problem. So does everybody agree this red right here is the height that they're interested in, correct? These are all 30, 60, 90s. Does everybody agree? So someone please tell me what this length is from here to here. 1.5. Thank you very much. So what side does that correspond to? 60. Thank you very much. This is 60. This is 30. So I now need to find what this length is. Somebody tell me what this length is. The yellow. Come on, someone say it. Yeah, 1.5 over radical 3. This is another practice problem because all we're doing is practicing the relationships. And I don't like that, so we're going to multiply by radical 3. So I'm going to have 1.5 radical 3 over what? 3. And what's 1.5 divided by 3? Yes. So this is the same as square root of 3 over 2. So this is equal to square root 3 over 2. So now somebody tell me what this is going to be.
It's radical 2.
Anybody? Tanner? What did you say?
Radical 2.
Yeah, this is radical 3. Now, is the process any different? Is the process any different? No. So now, how do I get to this? Divide by radical 3. What is radical 3 divided by radical 3? 1. Now I'm interested in this hypotenuse. What is this hypotenuse? 2. What is this leg? 2 divided by radical 3. So that's going to simplify to 2 radical 3 over 3. And now what's the height? What do I have to do?
4 radical 3.
Yeah, because I just multiplied by 2. So the height is equal to 4 radical 3 over 3. All right, that's a nice little review of what we did on Friday. All right, does everybody understand these are just little patterns to them, correct? Little formulas. All right, little formulas. All right, please make sure you know that these are on the SATs, the ACT, the 30, 60, 90s, plus will be a big part of your pre-calculus class. All right, that information that is right there is super important. All right, with that being said, pause. All right, so whenever you look at a right triangle, all right, and the first half of the chapter deals specifically with right triangles, and then believe it or not, they were able to figure out how it applies to more than just right triangles. It can be all triangles. All right, so with that in mind, all right, you're going to look at this guy right here. All right, this is a right triangle. All right, so I want everyone to write down SOHCAHTOA. Sometimes you'll hear kids call that SOHCAHTOA. All right. And sine stands for S. So you're going to write down sine. After you write a trig function, the variable has to come next. And the variable is an angle. So if I said the sine of R, all right, you would define the sine of R as O stands for opposite. H stands for, guess what? Hypotenuse. That's exactly correct. So if I was looking at that triangle and I was looking at angle R, what side would be the opposite? What side would be the opposite? R, S, or T? Here is angle R. Which one is opposite? R. This is considered the opposite. So the sine of R is equal to R over, what's the hypotenuse? T. Beautiful. C stands for, guess what? Not cos, but cosine. Sin is not sin, it's sine. All right. So we say the cosine of R. Everybody look at the cosine of R. Now, if this is the opposite and this is the hypotenuse, then what one is the adjacent probably? Right. This is considered the adjacent. So we're going to say adjacent over hypotenuse. Tan, we don't say tan, we say tangent. So the tangent of R is equal to, what do you think O is again? And what is A again? So that ratio would be what? R over S. Beautiful. Now, why do people find this confusing? They find this confusing because what if I ask you about the sine of S? Somebody tell me what the sine of S would be.
T over T. S over T.
S over T. So why do they say it's confusing? They say it's confusing because the opposite and the adjacent depend upon what angle you're referring to. Is everybody with me on that? The opposite side to angle S is S. So the adjacent could be considered the adjacent or the opposite, depending upon what angle you're looking from. What would be the cosine of S? R over T. What would be the tangent of S? How do we define tangent again? Tangent is opposite over adjacent. So we would say it's what? S over R. All right. Now, for those of you guys who might be going to plant next year, all right, here's how they will tell you to remember it. This is not mine. This is public school. This is how they want you to remember it. All right. SOHCAHTOA. Some old hippie caught another hippie tripping on acid. That's what they will say. That's how you can remember it. All right. Some old hippie caught another hippie tripping on acid. That's what they want. All right. Those of you guys who go into private schools, they will say, give you some legendary story about the famous Sakatoa Indian chief who discovered all of this. Sakatoa was his name. Sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent is opposite over adjacent. So that's how you can choose to memorize it. All right. I don't care how. Normally I tell you can't memorize or you shouldn't memorize things. But in this particular case, these have specific definitions. All right. So you can't really do the work unless you know the definitions. All right. That's what we're going to be talking about. All right. If you'll notice on your calculator, all right, that's a big part of your calculator, sine, cosine, tangent. All right. You will be using those a lot in the future. All right. So with that being said, we should be in good shape now. All right. We just did this over here. So I'm pretty happy with that information. All right. This again, for those of you guys who like to listen, all right, and didn't write it down as much, there it is right there for you. All right. Now, to save ourselves some time, all right, does everybody agree that trig is a ratio? Do we agree with that? So does everybody agree it becomes a fraction? Because it's a fraction, you can reduce it, correct? So instead of reducing it last, I like to reduce it when? First. So what's common here? 4. So instead of writing the fraction and reduce it, we're just going to divide each one of these by what? So this is 3, this is 4, and this is 5. So now I want the sign of J. What's the sign of J? 3 over 5. You are amazing. Listen to me. This has nothing to do with how good you are at math. Nothing. Has nothing to do with math. Come on now. If you know this, then this trig section is easy. All right. So now if I ask you what the cosine of J is, everybody would say the cosine of J is 4 over what? 5. Tangent of J is equal to 3 over 4. Now, if you're looking at me a little crazy, you're like, what are you talking about? Now's the time to raise your hand. Please do not let me go on if you don't know what you're doing. Now, can I ever do the sign of K? No, because the opposite is the same as the what? Hypotenuse. Is everybody with me on that? So I'll never ask you for the sign of the right angle. All right. Now we're going to do the sign of L. What does the sign of L equal? 4 over 5. What's cosine of L? 3 over 5. And what's the tangent of L? 4 over 3. Now, make yourself a note of this. This will help you in pre-calculus. Look at these two things. They're always going to be what? Equal. Look up here. The sine of L and the cosine of J are always going to be what? Equal. All right. So you kind of know that you've done it correctly. All right. And these are always going to be what of each other? reciprocals. All right, come on, guys. Let's knock this out. All right, let's jump over to number 3. What can I divide by here? I'm doing number 3, guys. That's no big deal. I skipped a little bit. What can I divide by? Some of you, let's do 12, right? So just cross out the 12, make this 2 radical 3. And make this what? 3. Beautiful. Okay, so here we go. So I want the sign of J. 3 over 2 radical 3. Just leave it like that for a moment, okay? I don't care about rationalizing right now. I care about, do you know the ratios? Does everybody hear me on this? Just do the ratios. So what's the cosine of J? Say it again. Yes, radical 3 over 2 radical 3. Now, in this case, we can just go ahead and simplify that to 1/2, right? And then what's the tangent of J? 3 over radical 3. Thank you so much. All right, please, you got to participate. If you're just writing it down, all right, you're not doing yourself any favors. What?
The sign of J, can't you like not have a radical in the denominator?
I don't want you rationalizing at this moment, I said.
Okay.
I don't want you rationalizing. All right. It's more important for you to get the ratio. All right. So now we're going to do sine of L. What's the sine of L? Yes. Because it's the same as what? Cosine of J. What's the cosine of L? And then tangent. Perfect, guys. I appreciate it. All right, now I'm going to try to, because we have some time, I need everybody to take out the calculator. Quickly, quickly, quickly. Now, the beauty of your calculator. If I have a right triangle, believe it or not, I can measure all of the angles. All right. You can measure and find them out without using a protractor. All right. So what I'd like everyone to do is, I'm trying to find angle T, correct? So here's what I need everybody to do. I'm looking for angle T, so I want you to circle that. And this is going to take some time, guys. Now, I want you to tell me the other 2 sides that are given. This and this. Everybody agree with that? Now, with respect to angle T, what is 14 radical 3? The opposite, the adjacent, or the hypotenuse? Opposite. And what is 34? Adjacent. So what trig function has opposite and adjacent? Tangent, right? So I want everybody to write down tangent of T equals, what's the opposite? 14 radical 3 over, what's the adjacent? 34. Now I don't even care about reducing it right now. That's not the idea. All right. So now if I said this, guys, look up here. I'm trying to help you. All right. Look up. Make sure you're with me. If I said 3x equals 10, how do I solve that? No. I didn't say what was the answer. I said, how do I solve that? Divide. If I say x plus 3 equals 10, what do I do? If I say x squared equals 10, what do I do? Find the square root. All right. So what I'm telling you is that you have inverse operations to solve equations. All right. Is everybody with me on this? All right. This was multiplication. The inverse operation is division. The inverse operation is subtraction. The inverse operation is square root. Now we are introducing another important function. The sine, cosine, and tangent are considered functions. So I'm trying to get to angle T. Does everybody agree with that? What's in the way? What's in the way of finding what T is? Tangent. Thank you for listening. How do I undo tangent? Everyone thinks it's division, but it's not. It's not multiplication. This is the tangent, and this is kind of in parentheses, but we don't write it in parentheses. It's understood to be there. It's not tangent times T. It's tangent of T. So I want everybody to look at the tangent button on the calculator. What's right above that? What do you think tangent -1 actually means? Opposite of tangent. But in math, we don't say opposite. We say they are what kind of functions? Inverse functions. So now listen, one of the most important things I can teach you today is this. I'm trying to get to T. I need to eliminate T. So I have to do the inverse tangent of both sides. I'm doing the inverse tangent of both sides. Now, what happens to inverse tangent and tangent? What do they do to each other? These guys cancel each other out. So I'm left with, and I want to better write this down, T equals inverse tangent of 14 radical 3 over 34. Now, before we calculate this on your calculator, I need everybody to hit the mode button on the calculator. We are supposed to be in degrees, not radians. So double check and make sure you're in degrees. If you look on the top of your calculator, the newer calculators tell you what function, what mode you're in. Is everybody in degrees? There's degrees and there's radians. You want to be in degrees always. All right. You'll learn about radians when you take pre-calculus. For now, we're in degrees because we're measuring in degrees. Is everybody with me on that? What? Where's your calculator? Come on, everybody needs a calculator out. Let's go. Let's go. I'm not sure what y'all are doing. If you don't have a calculator, I might be able to hook you up. Mode, it's spelled M-O-D-E. Hit the mode button. And then you go down to where you see degrees and radians. Make sure you're in degrees. All right. Now you can hit second tangent and type in now 14 radical 3 divided by 34. Now, come on, I'm not a babysitter. Everybody should know how to type in 14 radical 3 divided by 34. If you want to type it in as a fraction, you can hit alpha y equals and then hit enter and it'll come up with a fraction. Or you can hit alpha and x and it'll be a fraction. And then after you type all that in, hit enter and it will give you an angle measure. What is the angle measure? How much? Now I like to round to 3 decimal places, so we'd say 35.496 degrees. Everybody happy with that? Mr. Thatch, where's yours? All right, well, come on, buddy. This is important. You can't sit there. There you go, buddy. I got you. Is anybody not able to get 35.496? Everybody's good with that? All right, so here we go. I'm on number 5 now. Let's see how good I am. Everybody's looking at number 5. All right, I like to tell my kids we're looking for angle T. So I circle that. Then I circle the other 2 known parts. What is 7 and what is 18? Opposite and hypotenuse. Opposite and hypotenuse. Which one is opposite and hypotenuse? Sine. So everybody needs to write down sine of T is equal to what? 7 over 18. Because we are brilliant and you've been listening, now I'm going to hit what? Second sine. But I want you to say mathematically we are doing the inverse sine. So I want everybody to write down T equals the inverse sine of 7/18. I don't like -1 because some people think that's to a -1 power. That has nothing to do with it. It's not -1 power. That's just symbol for inverse. All right, that's symbol for inverse. So then t was approximately to 3 decimal places. Help me. 22 point what? 885 degrees. All right, one more here. Yes, sir. Because that means approximately. It doesn't equal, it's approximately. All right, now number 6, here we go. We're doing t, 34 and 87. What's the relationship between 34 and 87? What is 34? Adjacent. What is 87? Hypotenuse. So what function are we using? So we're going to write down cosine t is equal to what? 34/87. What trig function am I going to use now? Inverse cosine. And now help me out. 60 what?
66.995.
Everybody okay with that? I don't care if you put 67. I'm not arguing over decimals. All right. So I understand that now. That's the power, all right, of trigonometry. All right. You don't have to measure angles anymore. All right. You do not have to measure angles anymore. All right, here we go. Let's highlight 7, 8, and 9 for me, please. You can do 10 and 11 too. No, not 11, not 11. Now, for number 10, what do I want to do? Divide by what? So 8, 15, and what? And now you don't have to do what? Now you don't have to reduce at the end. All right. So don't worry about 11. I need you to do 10, right? It's memorizing work. All right. Everybody in here is capable of memorizing that. All right. Now it's sine of 30. Everybody type in on their calculator. Sine of 30. What is that? 1/2. Everybody good with that? Right now, I don't mind 0.5. Square root of 2/2. Eventually, you'll just be able to say that's like 0.707, right? Tangent of 45 is 1, correct? Yeah, tangent of 45 is 1. All right. Cosine of 60. Sine of 60. Yes, thank you. All right, so that's just typing it in. All right, let's type it in your calculator. All right, now please look at 18. Look up, look up, look up. There are 3 things that are going to be given, all right, or that you need, I should say, and they're going to give you 2 out of 3. So what's the relationship between 36, x, and 7? What trig function? Come on, I don't want the same person saying the right answers all the time. Does everybody understand? It's tangent. If you're looking at like, what are you talking about? Now's the time to ask. Does everybody agree? X is the what? Opposite. 7 is the adjacent. So the trig function with opposite and adjacent is what? So you write down the trig function, tangent. Then after a trig function is an angle. What angle are we talking about? 36. equals, what's the opposite? Over x over 7. Exactly right. Now, how do I solve for x? Nope. How do I solve dividing by 7? Multiply by 7. So x, I want everybody to write this down, 7 times tangent of 36. So now you take out your handy dandy calculator and you type in 7 tangent 36. Don't let someone else do it. You do it. 7 tangent 36. And x is approximately what? I mean, just come on, guys. I just want 3 decimal places. Oh, what? Okay, I'm not arguing. 5.086, 085. All right. Head back to 3rd grade or 2nd grade if you forgot how to round. All right. Anybody have any questions with that? All right, let's knock out 19. All right, I'm trying to find x. What is x defined as? What is 12? Opposite. So what trig function are we using? Opposite and hypotenuse. The first one, which is what? So sine. After you write a trig function, you always write the angle. Sine of what? 63 equals what? 12 over what? X. Now, basically, this is a proportion, but this is embarrassing. I deal with this all the time. Everybody look up on the board real quick. This is what your brain should be able to do. Your brain should be able to look at that and just say, obviously, X is 12 divided by the sine of 63. That's what your brain should be able to do. Now, let's say you're not understanding me. Well, I'm trying to solve for X, right? And I'm dividing by X, which means I'm multiplying by X, which means these two now are attached together with multiplication. So I'm going to get rid of this multiplication by doing what? Dividing. That's what you should be able to tell me. Now, let's just say for some crazy reason you get stuck. You're like, man, I forgot how he did that. Make it a what? Make it a proportion. And then you just cross multiply and divide the proportion. But I prefer everyone's just looking at that and say I multiplied by X and divided. Is everybody with me on that? So now, listen, here's what I want you to do. All right. Finish 19, 20, 21, 22, and 23. And I'll help you with the word problems for tomorrow. But listen, I almost feel like giving you a pop quiz when you come into class tomorrow and have you write down what does sine, what is cosine, and what is tangent. All right, those are 3 things that you cannot participate if you do not know. You cannot participate if you do not know sine, cosine, tangent, what those meanings are. So make sure you do. The sooner you do, the better it's going to be. Thank you for your attention. It was a great day. Thank you very much.